What is geology? Geology is the science that deals with the Earth's physical structure, substance, its history, and the processes that act on it. Geologists have discovered that Earth is about 4.56 billion years old. Geologists know how old the Earth is because of earth rocks, meteorites, and moon rocks. The formation of earth rocks such as zircon crystals can be traced back to approximately 4 billion years ago. Meteorites have been traced back to 4.56 billion years ago, and the oldest formation of moon rocks have been traced back to 4.45 billion years ago. Between the time that Earth was created and the present day, scientists presume that the Earth has seen many supercontinents. One of the major supercontinents is Rodinia, which was formed about 1 billion years ago during the Precambrian time. Another supercontinent named Pannotia was created about 600 million years ago at the end of the Precambrian time. Scientists named the changing and creation of the supercontinents the supercontinent cycle, which is also referred to as the Wagnerian cycle due to Alfred Wagner. During the Permian period, Pangaea, another supercontinent, was created, which consisted of almost every landmass. During that time, Pangaea was surrounded by only one ocean called Panthalassa. Approximately 200 years ago, Pangaea began to break apart, forming another minor supercontinent, which eventually led to the creation of our modern Earth. What is the Earth made of? The first layer of the Earth is the continental crust, which is an extremely thin layer in the ground that we stand on. The continental crust is like the skin of an apple because it is very thin compared to the other three layers. Plates divide the Earth up into different sections and float above the mantle. The plates typically move slowly underneath the crust, but there are times that the pressure is applied to different rocks, and it continues building until the rock shifts and breaks, allowing the pressure to be relieved, which causes an earthquake. The next layer of the Earth's crust is called the mantle. This layer is located directly under the sima. The mantle is about 1,800 miles thick and is the largest layer. The mantle is composed of very hot, dense rock and is able to flow under heavy weight. The flow of the rock occurs because of the significant ranges of temperature between 1,600 to 4,000 degrees Fahrenheit in the top and bottom of the mantle. Due to the movement in the mantle, the plates move as well. The following layer is the outer core. The outer core is found approximately 1,800 miles underneath the crust and is about 1,400 miles thick. The core is made up of metals such as nickel and iron that are at a liquid state due to the extremely hot temperatures, which can range anywhere from 4,000 to 9,000 degrees Fahrenheit. The final layer that makes up the Earth is the inner core. The inner core is approximately 4,000 miles from the Earth's crust and is approximately 800 miles thick. The pressure and temperatures within the inner core are extremely high. Temperatures can reach approximately 9,000 degrees Fahrenheit, and the pressure levels can reach 45 million pounds per square inch, which is approximately 3 million times the amount of air pressure you would experience if you were at sea level. This prevents any of the liquid metals from moving around and making the metals act as if they were in a solid state.
Plate tectonics. Now, how does plate tectonics have a role to play in the crust of the Earth? This is why I'm here to tell you. Earth's outer shell is divided into several plates that glide over the mantle, the rocky inner layer above the core. A plate acts like a hard and rigid shell compared to the Earth's mantle. This strong outer layer is called the lithosphere, which is 60 miles thick. The lithosphere includes the crust and outer part of the mantle. Below the lithosphere is the asthenosphere, which is a malleable or partial malleable, allowing the lithosphere to move around. How it moves around is an evolving idea. Your next question probably is, how many plates are there? There are 9 major plates, according to World Atlas. These plates are named after the landforms found on them. The 9 major plates are North American, Pacific, Eurasian, African, Indo-Australian, Australian, Indian, South American, and Antarctic. The largest plate is the Pacific Plate at 39,768,522 square miles. Most of it is located under the ocean. It is moving northwest at a speed of around 2.75 inches per year. There are also many smaller plates throughout the world.
The breakup of Pangaea that led to the creation of modern Earth is due to plate tectonics. Plate tectonics states that the Earth's outer shell, or lithosphere, consists of large rigid plates that move apart as oceanic ridges come together at subduction zones or slip past one another along fault lines. The pattern of the seafloor spreading indicates that Pangaea did not break apart all at once, but rather fragmented in distinct stages.
The rock cycle. The rock cycle is a cycle of processes undergone by rocks in the Earth's crust involving igneous intrusion, uplift, erosion, transportation, deposition as sedimentary rock, metamorphism, remelting, and further igneous elution. The water cycle is the cycle of processes by which water circulates throughout the Earth's oceans, atmosphere, and land, involving precipitation as rain and snow, drainage in streams and rivers, and return to the atmosphere by evaporation and transpiration. Tsunamis. Most tsunamis are caused by earthquakes generated in a subduction zone, an area where an oceanic plate is being forced down into the mantle of plate tectonic forces. The friction between the subducting plate and the overriding plate is enormous. This friction prevents a slow and steady rate of subduction, and instead of two plates becoming stuck. As the stuck plate continues to descend into the mantle, the motion causes a slow distortion of overriding plates. The plate is an accumulation of energy very similar to the energy stored in a compressed spring. Energy can accumulate in the overriding plate over a long period of time, decades or even centuries.
Here are some interesting facts about Yellowstone National Park and how it impacts geology. At the heart of Yellowstone's past, present, and future lies volcanism. Catastrophic volcanic eruptions occurred here about 2 million years ago, then 1.2 million years ago, and then again 600,000 years ago.
Now that you know a little bit more about geology, here are some geology jokes. Did you hear the one about the geologist? He took his wife for granted, so she left him.
What did the boy volcano say to the girl volcano? I lava you. What do you do with a dead geologist? Bury him.
Last one. How did the geology student drown? His grades were below sea level.